Hi, I am Preeti, doing my final MCA in Railtech Multitech Engineering College. My project domain is cloud computing and my project title is Oruta, Privacy Preserving Public Auditing for Shared Data in Cloud. Now let's see abstract. With cloud data services, it is commonplace for data to be not only stored in cloud but also shared across multiple users. But unfortunately, the integrity of cloud data is subject to errors due to the existence of hardware and software failures and human errors. Several mechanisms have been designed to allow both data owners and public verifiers to efficiently audit cloud data integrity without retrieving the entire data from cloud server. In this, we develop an novel privacy preserving mechanism that supports public auditing on shared data in cloud. We use ring signatures to compute metadata needed to audit the correctness of shared data. In this process, the identity of the signer on each block in the shared data is kept private from the public verifier, who are efficiently shared integrity without retrieving the entire file and the mechanism to perform multiple auditing tasks simultaneously instead of verifying them by one. This experimental result demonstrates the effectiveness and efficiency of our mechanism when auditing shared data integrity is achieved. Now let's see existing system. Many mechanisms have been recommended to allow not only a data owner itself but also a public verifier to efficiently perform integrity checking without downloading the entire data from cloud, which is referred as public auditing. In this mechanism, data is divided into small blocks where each block is independently signed by the owner. A public verifier could be a data user who would like to utilize the owner's data via cloud. Unfortunately, our current mechanism only focuses on personal data in cloud. In previous public auditing mechanisms can actively be extended to verify shared data integrity. But however, a new significant privacy issue introduced in the case of shared data with the use of previous mechanism is the leakage of identity privacy to public verifiers. Now let's see disadvantages of an existing system. It fails to preserve identity privacy on shared data during public auditing, will reveal significant confidential information to public verifiers. And to protect this confidential information, it is essential and crucial to preserve identity privacy from public verifiers during the public auditing process. Now let's see proposed system. In this project, to solve the above privacy issue on shared data, we recommend Oruta. In Oruta, we utilize ring signatures to construct homomorphic authenticators so that a public verifier is able to verify the integrity of shared data without retrieving the entire data, while the identity of signers on the each block in shared data is kept private from the public verification. In addition to this, we further extend our mechanism to support batch auditing, which can perform multiple auditing tasks simultaneously and improve the efficiency for multiple auditing tasking. Meanwhile, Auruta is compatible with random masking, which has been utilized in worldwide RL and can preserve data privacy from public verifiers. Moreover, we also leverage index hash tables from a previous public auditing solution to support dynamic data. It is an high-level comparison among Oruta and privacy preserving is recommended in the above previous mechanisms is presented. Now let's see the advantages of proposed system. In this Oruta, a public verifier is able to correctly verify the shared data integrity, and he cannot able to distinguish the identity of the signer on each block in shared data during the process of auditing. We use ring signatures generated for not only able to preserve identity privacy but also to support blockless verifiability. During public auditing, the third-party auditor is able to publicly verify the integrity of shared data of group users without retrieving the data. In correctness, the third-party auditor is able to correctly detect there is any corrected block in the shared data. Unforkability. Only a user in the group can generate valid verification information on shared data. We can easily privilege the identity privacy using the third party auditor cannot distinguish the identity of users signed in each block. Now let's see the hardware specification. Processor used is Pentium 4, speed 1.52 GHz, RAM 1 GB, hard disk 160 GB. Next, software specification. Operating system used in this project is Windows XP or Windows 7. Language used is Java. Front end we use JSP, Servlet, JavaScript. Application servers are used Apache, Tomcat 7.0 or Glassfish server. IDE we use in this is NetBeans 7.0 and backend of this project is MySQL 5.5. Now let's see the system architecture. In this architecture, there are three parties: cloud server, third-party auditor, and user. Users are divided into two types, such as original users and a number of group users. The original user and the group users are both the members of the group. Group members are allowed to access and modify shared data created by the original user based on access control policies. Shared data and its verification information are both stored in the cloud server, and the third-party auditor is able to verify the integrity of data shared in cloud server on behalf of the group members. In this architecture, if when a user wishes to check the integrity of shared data, it first sends an auditing request to the third-party auditor. After receiving the auditing request, the third-party auditor generates an auditing message to the cloud server and retrieves an auditing proof of shared data from the cloud server. Then the third-party auditor verifies the correction of the auditing proof. Finally, the third-party auditor sends an auditing report to the user based on the result of verification. These processes are done by using the homographic ring signatures. Next, let's see the models used in this project, such as Data Owner Module, Homomorphic Authenticable Ring Signature Module, Third-Party Auditor Module, Data User Module, and finally the Data Sharing Module. Now let's see how we run our project. In front end, open NetBeans. Click File, Open Project, location of the project, open project name. Then right click on the project name, select Properties, then Libraries, then add jar/folder location of the project name and click the Add Remove jar files and select OK. Front end is over. Now back end. Select all programs. In that, click MySQL Server 5.1 and select MySQL Server command line. Next, select the source location of the database and filename.sql. Now right click on the project and run. Since our application is cloud computing, we can run our application project in any web browsers using internet connection. The link for our project is http://www.orutaclouds.appspot.com. Using this link, we can access our project with net connection in anywhere, anytime. After running the project, our home page will be look like this. Auditor privacy preserving public auditing for shared data in cloud. First, you have to register a valid user. For that, you must provide the information such as username, gender, country, mobile number, password, address, gender, email ID, and then you have to check the user account is registered or not. Now let's log in using the username and password. The user account created will not be activated, yet it must be verified by the public verifier. Now log out the user account and log in the administrator account using username and password of the administrator. Now the administrator login page is activated. In that, select response and authenticate member. Now the administrator should activate the user using the response and activate users. Now the user account is activated and a message appears when you click the active button such as your user account is activated. In this administrator login page, the administrator can verify the user details. He has permission to delete or active an user. Now log out the administrator and come back to the user login page. Select the username and password of the activated user. Now your user account is activated. After we log in the user account, our user account main page will be like this. It consists of the options like user profile, transfer file, file details, auditor, share data files, accept keys and logout options. First of all, let's see the user profile. In the user profile, we can see the details of the users such as username, password, gender, address, country, state, mobile number, email ID, member ID, and if you want we can also edit these files, the user using this account. Now the file uploading process. In order to upload a file, we must register a username. We have already registered the username. Using that username, we also have member ID. Then we should upload a file. Next, user upload detail file details. In that, we used to see the whatever files we are uploaded in the cloud data server. Now file transfer process. In order to transfer a file, we must select a data user and the file whom we want to share. Next, auditing process and verification. To audit a process, we must select the username and select the file which we want to audit and select the auditing request to the third party auditor. Now the auditing verification process. The administrator verifies the key request of the user and accepts the file and activates the key. Next process is public key generation and file downloading process. Now the administrator activates the key request, accepts the file and key is activated. Next is the public key generated process. As soon as the administrator activates the key, after verifying the file and accepts the key password, the public key is generated. This public key is sent to the group user who sent the auditing request. Now the user can get the auditing proof and go to the next process, public key as authentication. Now the user can download a file using this public key. Next, the file download process. As soon as the user uploads the public key and downloads the file is downloaded by the user. In this process, we use the homographic ring signatures authenticable as to verify our data without getting a full data integrity to the third-party auditor. Since the third-party auditor is not able to get the full data as well as doesn't know which user is using or sending the files. This is the main theme of the Auruta privacy preserving public auditing for shared data in cloud. Now log out and return to the home page and verify all the process. Next, let's see the conclusion. In this project, we recommend Oruta, the first privacy-preserving public auditing mechanism for shared data in cloud. We utilize ring signatures to construct homomorphic authenticators, so the third-party auditor is able to audit the integrity of shared data, yet cannot distinguish who is the signer on each block, which can achieve identity privacy. To improve the efficiency of verification for multiple auditing tasks, we further extend our mechanisms to support batch auditing. Thus, this mechanism works on static groups only and preserves the identity of the signer on each block from the third-party auditor of all the shared data in cloud. Thank you.